Hello everyone. In this presentation we're going to talk about how to use MoorDyn with WEC-Sim. So brief overview of the contents. Firstly, I'll talk about what MoorDyn is, where you can get the necessary MoorDyn files that you'll need to use MoorDyn with WEC-Sim. Then we'll step through the WEC-Sim RM3 example that uses MoorDyn, check the results of that model. And then I'll talk a little bit about how you can modify the MoorDyn input file to simulate your own mooring designs. Okay, so first of all, MoorDyn is a lumped mass mooring line model for simulating the dynamics of mooring systems. And it can be used with a wide range of floating offshore structures. We're most interested in using it with wave energy converters, but it's also used a lot with floating offshore wind turbines. And in WEC-Sim, if we just want a simple mooring model, we can use a spring damper that's just going to provide some kind of restoring force, but that's very simplistic. And what MoorDyn does is actually discretize the whole mooring line into a series of point masses, as you can see here, that are connected by spring dampers. And with this approach, you can have hydrodynamic loads acting along the mooring line. You can see where the mooring line is touching the seabed and when it's lifting off from the seabed. You can also include weights and floats along the mooring line to simulate some more complex mooring designs. These kind of capabilities are really important to get a more accurate estimate of the loads on the mooring line, but also to get a more accurate estimate of the dynamics of the floating structure and how it's going to move with these mooring lines applying forces to it. Okay, so you can get the necessary MoorDyn files from this location on GitHub. It's github.com/WEC-Sim/MoorDyn. So this is a repository on the WEC-Sim organization where we have the MoorDyn binaries that you'll need, regardless of whether you're using Windows, Mac OS, or Linux. The header that you'll need, and a MATLAB script that'll work with WEC-Sim. You can just download this whole folder as a zip file, and then once you've downloaded it, unzip it, and the contents of this folder, you'll just want to grab all of them and copy and paste them into this location in the WEC-Sim repository. So you copy paste all these files, paste them into WEC-Sim/source/function/MoorDyn. And once you have all of these files inside the MoorDyn folder, then you're ready to start using MoorDyn. Okay, so now that you have all of the MoorDyn files that you need, you can head over to an example in the WEC-Sim applications repository. So if you have already downloaded or have cloned that repository, you should see a folder called Mooring inside that folder. And then within Mooring, there should be another folder called MoorDyn. And you should see these folders and files inside the MoorDyn folder. And it'll look like a normal WEC-Sim model. You've got your Simulink file there, your WEC-Sim input file. The main difference at this top level is that we also have this mooring folder. And if you look inside the mooring folder, this is where your lines.txt MoorDyn input file is going to sit. A couple of other differences from a normal WEC-Sim model. Inside the Simulink file, we have this extra MoorDyn block, and you should be able to see that in the Simulink library browser. If you look at the WEC-Sim library, you should see the MoorDyn block there. And then in the WEC-Sim input file, you should notice these extra lines that just have a bit of information corresponding to the mooring design. So those are the key changes at a high level. In order to run this model, you might need to install, if you haven't already, the MinGW C++ compiler in order for MoorDyn to run correctly. Okay, assuming you have everything set up correctly and you have your C++ compiler, when you run the model, you should see this console window pop up. And for the example case, everything should run smoothly and it shouldn't throw any errors. But when you start running your own models, it's good to keep an eye on this console window and what information it's printing. It can give you some helpful information if the mooring model is failing. If the convergence isn't happening quite correctly, it'll give you some information about that. But yeah, for the example case, everything should run perfectly fine. And once it's finished running, you can navigate to the output object that WEC-Sim creates. And within there, you should notice this structure called MoorDyn, which has all of the data that MoorDyn's produced. And if you go into the individual line structures, you can then see the tension time series data that MoorDyn has been computing. You can plot it directly there in MATLAB. These options are actually determined in the MoorDyn input file. So you'll notice in your lines.txt file, you have fair10.4, fair10.5, fair10.6, and that's the data that's actually being saved to this structure. And yeah, if you wanted some other data to be saved by MoorDyn, then you could modify this line in the text file. Okay, so hopefully you've managed to run the example case okay, and everything's working correctly. And if so, you're probably at the point where you want to modify the MoorDyn input file to simulate your own mooring designs. And I would say, for a comprehensive explanation of the different sections of that input file, please have a look at the MoorDyn documentation because it covers everything. But just at a high level, the MoorDyn input file is split into these 5 sections really. There's the line dictionary section where you can define the line types. And all the necessary properties that you need, whether it's chain or rope or nylon or whatever. And then the next section is the node properties. So, which nodes are connected to a vessel, a floating body, which nodes are fixed, probably your anchor points, and then some other connections which can be used to combine different types of mooring line. So yeah, you need to define the locations of those nodes. And then some information about the lines, which, first of all, how many lines, but then also the line type that you're using for each line, the length of the line, the number of segments. And it's this section that you actually need some information from in your WEC-Sim input file. So firstly, the number of lines, that has to match how many lines are listed in this line properties section. It's over here, so 6. We've got 6 lines in the lines.txt file, and then we've got 6 lines being defined in the WEC-Sim input file. We also need to define the number of nodes in the WEC-Sim input file. So you can see here for lines 1 through 3, we have 16 nodes, which corresponds to these 3 lines where we have 15 segments being defined. So it's just the number of segments plus 1 because you have nodes at both ends of the line. And then similarly for lines 4 through 6, we have 6 nodes because we've got 5 segments being defined in the MoorDyn input file. The next section in this file is covering the solver options. So the most probably the most important variable here is the time step that you're using in MoorDyn. It'll be a different time step to what you're using in WEC-Sim. MoorDyn uses a Rungercutter 2 time integrator, and it typically requires quite a small time step. So if you are running into problems with your mooring model, it could very well be that your time step just needs reducing. And then the last section here is the outputs that you want saving. And again, in the documentation, there's a clearer explanation of the different options that you have there for outputs. Okay, so I hope that was a helpful introduction to using MoorDyn with WEC-Sim. And if you have any more questions, please post them on our WEC-Sim GitHub issues board, and we'll do our best to get back to you and help you out. But yeah, thanks for listening.